All right, this is question 2 from the 2018 AB Calculus test. This is taken straight from their website, straight from the problem. Particle moves along the x-axis with velocity given by that equation v of t. Looks nasty, but you have a calculator, so no big deal. T exists from 0 to 3.5. They didn't tell you time, so we don't want to say seconds or minutes or anything like that. They didn't give us any units in this problem. We know the particle's position is -5 at time equals 0. That is going to come into play at some point. All right, this is a very, very quick problem. Not a lot of math going on here, not a lot of things you need to work through here. I was very excited a couple years ago when we had this problem. This is a problem that students tend to do very well on. I would anticipate a problem like this or some questions like this on your test that you'll be taking this year. It's straightforward. It asks you to do a lot of stuff. It asks you to pull a lot of knowledge. They have to cram a lot of knowledge into 2 problems, so something like this would be a decent problem to get some calculus knowledge, for you to show some calculus knowledge. So, Part A. Part A is simply asking us to find the acceleration of the particle at 3 seconds. No problem. We did this a long time ago. If you want the acceleration at 3 seconds, if you have velocity, the acceleration is simply just the derivative of the velocity. So A of 3 would equal V prime of 3. I have a calculator. I am not about to take that derivative by hand. Don't even pretend to do it. Don't try and do it. Don't start doing quotient rule. Just grab your calculator, let your calculator do the work, and your calculator should give you -2.12. This problem doesn't have units, so I don't even have to worry about units here, and that's what makes this problem even easier. I wouldn't anticipate that. I'm thinking they're going to have a lot of units on this test. But if they don't, no big deal. Don't bother just writing units or units squared or anything. Don't. If they don't put units there, don't put units. This works out to be -2.12, and you get a point for this. That's a point that every single one of us should have. Every single one of us should be able to take the derivative with our calculator and get that value. Nobody should be getting a 0 on this problem. Part B, same thing with Part B. Part B is relatively easy as well, though there's one little trip up. Part B is asking us for the position of the particle at 3 seconds. Well, I have velocity. The derivative of velocity gave us acceleration, so if I integrate, it doesn't give me position. If I integrate, that'll give me the displacement, right? It's something that we just finished doing. That will be on there. And so integrating the velocity from 0 to 3, that will tell me the displacement. That will tell me how far it moved. I also have to make sure I add on my starting position, and my starting position was that x is equal to -5 at time equals 0. So I need to add that in there as well. Again, I have a calculator. Don't start integrating by hand. Just punch on your calculator the integral. When you punch that integral up, you'll get 3.24 for the integral. And then I have to add on that -5 to that 3.24. And that will give me the particle's final position of -1.76. There's a lot more points to this problem than there were to Part A. For this, you get a point for knowing that you're going to have to integrate the velocity, so somehow showing that you're going to do that. You get a point for knowing that -5 has to come into play, and then you get a point for actually doing it correctly. So 3 big points here that are really, really easy points. We should be able to have those as well, and now all of a sudden, if you can do Part A and Part B, not a lot of work, you're already sitting at 50%, and if they're grading this the same way they've done in the past, you're passing this test. So it shouldn't be that scary of a thing. We should be confident as we walk in there. Well, we're not walking in anywhere. We're walking into somewhere in our house. But when we sit down to do this, we should be very, very confident, not afraid of this test at all. Part C. I was surprised by Part C when I saw this a couple years ago. I would have thought they would have asked this in a different way. They asked it so straightforward. Who knows how they're going to ask it this year? They wanted to, in Part C, have you evaluate the integral from 0 to 3.5 of v of t. And then they wanted you to integrate from 0 to 3.5 the absolute value of v of t, and then you were to explain what each of those integrals actually gave you. No work to do except for punching on your calculator, so you grab your calculator and you punch this one up, and you get 2.84. You grab your calculator and you punch this one up, going into catalog and finding ABS for absolute value, and you should get 3.74. No units to worry about, and so I don't have to worry about putting any units there. If we did, it would just be a distance of some sort, meters, inches, whatever. And then we just have to explain what these are. We know this. We went through this very much so. The 2.84, the integral of just the velocity, just like I mentioned in Part B, that's the displacement. And we'll be specific. That's the displacement from 0 to 3.5. Because I don't have to say it's the displacement. If I just say it's the displacement, does that mean every time the displacement's always that? No, the displacement is specifically from 0 to 3.5. What if I throw the absolute value? If I throw the absolute value around it, that will be the total distance traveled by the particle. And so you just got to make sure you get those explanations in there. Like I said, I was very, very surprised that they made this problem so straightforward. They didn't kind of convolute it into, hey, let's talk about this and try and direct you in different ways. They just straightforward said, do this. And so very shocking that they had it this way. But hey, that's your win. Let's take it. As far as points are concerned for part C, we're going to get 3 points for this. You're going to get a point for having both of these values correct. If either one's wrong, you don't get the point. And then you get a point for stating that this one's the displacement, and you get a point for stating that that one's the total distance traveled. Outside of careless mistakes, mispunching something on your calculator, etc., we should be sitting on those 3 points as well. So I'm looking at 7 points right now out of 7. This is not a tough problem at all. I would be ecstatic if we could see a problem like this year. We were really, really happy in 2018. Many of my students, when we went through these problems a couple of days later, when they became released, many of the students were very, very excited and very happy to see that they had those answers. They remembered that those answers were there. So, moving on to part D. So in part D, we have a second particle, and they give us the position of that second particle. They call it x sub 2 of t, since it's the second particle. And they tell us that that position equation is t squared minus t over the course of 0 to 3.5, and what they want to know is when are their velocities the same? When is the velocity of particle 1 the same as the velocity of particle 2? Well, I have the velocity of particle 1. That's given to me in the problem. That's that nasty equation way up here. That's highlighted now. Okay. The other velocity I've got to get from my equation. Well, you know, they went really, really hardcore in coming up with an equation to make you take a derivative of. No, they didn't. This is a super duper easy equation to take a derivative of. The velocity of particle 2 is simply going to be 2t minus 1. We want to know when those velocities are equal, and so we're going to take that 2t minus 1 and set it equal to the velocity that I've got highlighted up top, and I'm just going to write it as v of t. You're not going to do any of this by hand. You're going to grab your calculator and let your calculator do the work. And when you set those equal to each other, you should see that they cross at time is equal to 1.57. I don't have any units there, and so it's just 1.57. There was no explanation needed. And that really shocked me. I thought for sure that they would be asking for some type of explanation or something, but they didn't. They simply just wanted you to find the time. Extremely straightforward. There's 2 points here available to you. You get 1 point for doing the very difficult task of taking the derivative of t squared minus t, and you get 1 point for coming up with that 1.57. Many of my students, after we took this test in 2018, after the questions were released and we went through them, many of my students were very confident that they scored 9 out of 9 on this problem. We had a lot of high scores because this problem is very straightforward. I could see a very straightforward problem like this on this test this year. I don't see the AP test going above and beyond making this super duper difficult. I see them just trying to see, do you know your stuff? And this is a question that's simply, do you know your stuff? So I hope that you did very well on this problem, and hopefully we get one like this, and so we can do well on this problem when we take this test on May 11th. So there's question 2, and until next time, have a great day and stay safe.